Hi, my name is Taylor Patterson. I'm a research associate and developer on the NiCE project at Oak Ridge National Lab. Today I'll be sharing with you a demonstration of the CAEBAT plugins in NiCE, computer-aided engineering for batteries. After starting NiCE, we must first create a CAEBAT model item. A brief side note, in this video I'll be demonstrating the use of NiCE on Mac OS X. NiCE is fully compatible with Windows, Mac, and Linux operating systems, and binaries are available on the project website for 32 and 64-bit architectures on all three operating systems. Back to creating a CAEBAT model item. As with all items in NiCE, we achieve this by clicking on the plus sign in the Item Viewer tab. In the dialog box that appears, select CAEBAT Model and click OK. The current capabilities of NiCE provide for several different battery configurations. Additionally, the time loop settings and ports can be adjusted. Clicking on the Component Details tab presents a table of battery components. Each of these components can be selected in order to inspect and edit their details. For this demonstration, I will use the default settings provided. Don't forget to save the contents of this form prior to processing. Here I will select to export this form's content to the CAEBAT input file format. Once processing has completed, as indicated by the status bar at the top of the page, we are ready to move to the simulation launch stage. As was previously the case with the CAEBAT model, we initialize a CAEBAT launcher by clicking on the plus sign in the Item Viewer tab. This time we select CAEBAT launcher in the dialog box. In the Input File drop-down menu, select the .comp file that was previously produced by the CAEBAT model. Make appropriate selections for the thermal, electrochemical, and electrical configuration files. Select the computing platform from the drop-down menu on the far right side of the form. Here we will launch on a machine named Livingston. The viewer should note that this is a remote machine and not the machine that I am running the NiCE user interface on. Again, we save this form prior to selecting to launch the job from the Process drop-down menu and clicking Go. A prompt appears to log into the remote machine. After entering an appropriate password, processing begins. I'll step aside for a bit while we wait for the battery simulation to complete. Now that the simulation is completed, as indicated by the status line, we can take a look at the results by selecting the Output Files and Data tab. Here we can view the results of standard output and standard error, as well as several other files produced throughout the simulation launch and run process. One file that we'll take a closer look at in the analysis stage is the output battery 1.1 silo file. For analysis of visual output, we must return to the Item Viewer tab to create a Visit Viewer item. We create a Visit Viewer item by following the same item creation procedure as before. This plugin serves as a front end in NiCE to the Visit, Visualization, and Graphical Analysis tool previously developed as part of the DOE's Advanced Simulation and Computing Initiative. To take a closer look at the previously mentioned file, we select it from the Data Sources drop-down menu. Next, select Artifacts by clicking on the Add button next to the Analysis Configuration table. For this demonstration, I will select 3 different artifacts. Save the form, select Generate Analysis Artifacts from the Process menu, and click Go. I'll step aside once more to wait for this to process. After processing has completed, select the Analysis Artifacts tab to view the output files. At present, NiCE is only capable of displaying static images rendered by Visit, but we are working to integrate more of Visit's capabilities into the plugin. This concludes the demonstration of the CAEBAT tools in NiCE. Thanks for watching the video. I hope you found it informative. I also encourage you to watch the videos of my colleagues and to visit our website to submit any comments or questions, as we're always looking to improve NiCE.